ओके, बिस्मिल्लाहिर्रहमानिर्रहीम। आज के इस दूसरे सेशन को हम स्टार्ट करते हैं। ओके, समथिंग अबाउट द टर्मिनोलॉजी and the notation which is used in this book and in this course as well. So let me use the annotations. So the input signal जो कि यहाँ U से हमने the input signal represented as U take on the scalar values. For example, k is then 1. And similarly, if the m is 1, then in that case, we have a single input and single output system. But if the values are different, then we have a multiple output and multiple input system. So if in the case we have a single input, then k will be equal to 1. And if we have a single output, then m will be equal to 1. Otherwise, if they are not equal to 1, then we have multiple inputs to the system. And similarly, we have multiple output from the system. इसको हम थोड़ा सा एक दफ़ा रीड कर लेते हैं ताकि जो जिस अंदाज में लिखा गया है वो भी हमें समझ में आ जाए. When the input signal u takes scalar values, that is k is 1, the system is called single input, और इसको SI से denote, single input. Otherwise, it is called multiple input. And this is the case for input. And when the output signal y takes scalar values, the system is called single output. Otherwise, it is called multiple output system. So when there is no state equation and we have is simply the output equation, then the system is called memoryless. So in the case of absence of the state equation, जिसमें x की जो है वो value mention होती है, so if we do not have is we have only the output equation, which is the relation between the input and the output. So there is no state inside. So that means for a state to exist, we need a system which has memory inside. तो डिजिटल कंप्यूटर सिस्टम की लैंग्वेज में हम ये भी कह सकते हैं कि if a system has memory and using that memory, then it must have a state equation as well. इसी को थोड़ा सा मज़ीद एक्सप्लेन कर लेते हैं कि we then have the single input and single output systems. Similarly, we have multiple input and single output systems and multiple inputs and multiple output systems. And similarly, we have single input and multiple output systems. So there are two combinations for each case which can be established like this, and similarly like this. So there are four classes of the systems कि जिसमें जो है वो हमें different equations जो है वो बनानी पड़ेगी. इन equations को देख लेते हैं कि ये कैसे equations जो हैं ये आएंगी. एक तो memoryless जो system है उसकी equation आपने देख ली कि if there is no state equation, only we have a relation between the input and the output. So in that case, we have a system which is called memoryless. Again, the both equations. अब थोड़ा सा एक्सप्लेन कर रहे हैं कि A, B, C और D को थोड़ा सा एक्सप्लेन कर रहे हैं. और इसी तरीके से लीनियर टाइम वेरिएंट और लीनियर टाइम इनवेरिएंट सिस्टम्स की बात करते हैं. So when all the matrices are constant, and we have time which is greater than or equal to 0, the system 1.1 is called a linear time invariant system. So in that case, we have the matrices with constant values. There is no variable inside. तो हम इसको simply ax a लिख सकते हैं because it is not depending on the time. So the value of a remains the same, b remains the same, and c remains the same, and d remains the same. In the general case, 1.1 is called a linear time varying system to emphasize that time invariance is not being assumed. तो उस सूरत में जब ये जो है it is also depending on the time, then the system is a general system and we say it is a time varying system. So in chapter 3 जो कि lecture 3 भी है इस book में, discusses the impulse response for these systems. जो linear systems की दोनों categories के लिए impulse response जो है उसको consider किया. So the terminology indicates that the impulse response concept applies to both kind of linear systems. However, the transfer function concept is meaningful only to the linear time invariant system. तो जब भी हम transfer function की बात करेंगे, तो we are primarily working with the linear time invariant system. जो कि मैं पहले भी बता रहा था कि these are primarily जब हम कंप्यूटर पे उनको प्रोसेस करने जाएंगे, then we have the discrete linear time invariant systems. उसके लिए जो एक सब क्लास है उसको हम प्राइमरली उस वक्त फोकस कर रहे होंगे. So this is the concept how these matrices primarily work, and if they are primarily remain the same throughout the system operation, or they change over time during the lifetime of the system. Then there's a short form of the formulas, because these formulas, to write these formulas every time, book has used a single notation for these two formulas, and this single notation is for time invariant and for time variant cases both. For example, in the case of continuous linear time variant systems, and in the form of continuous linear time invariant systems, they have made these two formulas. So whenever there is a time presence, this is a time varying system, and both equations are written in one equation, in the form of one equation. Similarly, if t is absent, there is no t with a, so constant value. So this is linear time invariant, and this is also continuous because c is there. We have discrete case as well. So this is how the formulas are arranged and written in this book. तो ये इसकी short form है कि किस तरीके से इसको short form में, and also some ambiguous type of notation के वो इसको represent कर रहा है CLTV and CLTIS के साथ, so that if anywhere written CLTV, so that means it's a continuous linear time variant system, and it is continuous linear time invariant system. So we have discrete case as well, as we know that the discrete case is usually represented with the difference equations, and those difference equations are written in this format, that the time advance, so the time in future, the future value based on the existing value. So this is the concept. So this makes the equation the discrete. बाकी देखिए सब सेम है, सिर्फ डेरिवेटिव जो है उसको एक डिफरेंस जो है टर्म जो है उससे रिप्लेस कर दिया. So All the terminology this introduced for the continuous time systems is also applied to the discrete case as well. But there is a difference because the in the case of the discrete, we they are using this interval, the n 0 1 2. This is a subset of natural numbers. हम इसको positive integer primarily कह सकते हैं because they include zero as well. Positive integers, because positive integers include zero as well. And in the case of continuous, we have a interval from 0 to infinity because it includes the real values, जिनको हम जो है वो फिर अगर discrete case के सूरत में simulate करते हैं, then we have to use the fractions for those values. So this is the discrete case. As you can see, the equation is the same. The only difference is the use of difference equation, difference instead of derivative. Okay, यहाँ कोई सवाल आपके ज़हन में आ रहा है? This is just the terminology. And in this slide, it just show the short form of discrete linear time invariant systems. So it just uses the x plus instead of x t plus 1. So just using a short form so that formula can be written in one line only. ठीक है, इसको थोड़ा सा रीड कर लेते हैं. इन डिस्क्रीट टाइम सिस्टम्स द स्टेट इक्वेशन इज ए डिफरेंस इक्वेशन, जबकि इससे पहले जो था वो स्टेट जो इक्वेशन थी दैट वाज ए डिफरेंशियल इक्वेशन ऑफ ऑर्डर 1 इंस्टेड ऑफ ए फर्स्ट ऑर्डर, लिखा हुआ नीचे ना, इंस्टेड ऑफ ए फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन. However, the relationship between input and output is almost same, यानी analogous है. For a given input, we need to solve the state, जो कि अभी डिफरेंस की सूरत में दी गई है, to determine the state and then replace in the output equation to find the output. The process is the same for the case of discrete as well. Okay, the next topic is related with the block diagram, and this is a simple section in which the system is primarily represented in the form of a block and in the form of a process or plant. Okay, process or plant. Plant is the usual terminology which is used in the control, but in some places process is also being used. So this block diagram is also in few books represented in a way which shows the time relation, that it is the process is vary over the period of time. So it is convenient to represent system by the block diagrams, and these diagrams usually a compact representation for the complex equations. तो primarily ये equations की ही एक representation है. जैसे एक सवाल किया गया था कि x जो है उससे लिंक करता हूँ, ये उससे डायरेक्ट लिंक तो नहीं करना, बट एनी हाउ दिस वी कैन रिप्रेजेंट सिस्टम, we represent the system in the form of the diagrams, which is a usual way of representing system in control theory. So two-port block diagram in figure 1.1, because there is an input port and there is an output port. So represents a system with the input U and the output Y. Remember, this dot shows the time, okay, the time variation, where the direction of the arrow specified कि जो है वो इनपुट किस तरफ से आ रही है और आउटपुट किस तरफ से आ रही है. ठीक है. So I need to just hide this to represent the last two lines. Okay, although not explicitly represented in the diagram, one must keep in mind the existence of the state. which affects the output through the initial condition. So remember there is a state inside. अगर ये सिस्टम जो है वो मेमोरी लेस नहीं है, then we must have a state equation as well. Okay. So we can have the parallel, the systems which are arranged, the subsystem are the components which are arranged in parallel and in cascade format, and also in a negative feedback format. So these are, we will now discuss these block diagrams. Okay, interconnections. So interconnections of block diagram are especially useful to highlight the special structure in the state space equations. To understand, we primarily assume there are two blocks, P1 and P2. And we have primarily consider the parallel block. We have primarily the output of P1 as Y1 and P2 as Y2. And we have the input U. So considering each block a separate block, okay, considering U as U1 here and U2 here, we can write individual equations. For example, for this upper block, we can write an equation for P1, and this equation is also valid if we can write here U1 and here Y1. So for that case, we can write the same equation P1, and this is the true for this case as well. And similarly, for the second process P2, we can write another expression. So by doing this, we now have two systems or two plants with us. Now extending these concepts ahead up in the equations, obviously we have to link so that we can primarily formulate a single equation for the parallel case and a single equation for the cascade case. So in this diagram, the two equations which are given, the general procedure to obtain the state space for an interconnection consists of stacking the states of the individual subsystems in a tall vector X and comprising the differential using the state and output equation of the individual blocks, and the output equation is also obtained from the output equations of the subsystems. For example, y then become the y1 plus y2, and similarly the y1 become here u2, for example, become the y1 which is coming from the previous case, and then we can find the y2 which will then become equal to 1. So this is the general procedure which is explained in the book using this description over here. I have to move this over here. So considering the case of parallel in which we have U is primarily, U1 is primarily U, And similarly, U2 is primarily U. So we use this in this equation. So instead of U1 and U2, we write U only. So only U is written, the subscript is dropped. And similarly, this subscript is dropped. And we are considering only U. Then we can write the equation in this form, which is for the parallel interconnection. So for the parallel interconnection, we can write the equation in this. ठीक है, ये एक सवाल भी था कि किस तरीके से ये मैट्रिसेस जो हैं ये प्राइमरीली आती हैं, बट द मैट्रिक्स जो है वो जो हमने सीखा था पहले, हाउ टू रिप्रेजेंट इक्वेशंस इन द फॉर्म ऑफ मैट्रिसेस, सेम concept is used over here, and we can then convert the equation into a one equation. Okay. Similarly, we can extend in the parallel case another block like P3, and then we have another column, for example, x3, the derivative of x3, and similarly the next part comes in, and so on. We will having examples of the cases in our lectures in future as well. So this is the case of parallel blocks configuration. Okay, now moving towards the cascade case. Okay, as you can see, in the cascade case, the situation is a bit different, and we have U is primarily U1, and here we have Y1, which then become equal to U2, and similarly we have Y2, which then become equal to 1. So when we make these changes here, we have U is equal to U1, Y is equal to Y2, and similarly we can replace it, Z is equal to Y1 is equal to U2. Then we can also have a cascade interaction equation like this. Okay, so in the next paragraph, it is also written that we can decompose into the earlier equations, two equations. अगर हम रिवर्स जाएं तो, okay. So this is the way how the parallel and the cascade configurations can be generalized and implemented in a bigger and complex system case. ठीक है, हमें याद कुछ नहीं रखना, हमें सिर्फ ये जहन में होना चाहिए कि this is a representation which is primarily a cascade representation. ये जनरल solution का जो तरीका है ना वो बता रहा है कि किस तरीके से हम जो है ना इस solution की तरफ proceed करेंगे. That's it. Now the another case we have discussed is related with the negative feedback. Okay. So in the negative feedback case, we have some different type of equation. In this case, we have U1, which is actually a subtraction of U minus Y1 here. Because U is coming in from the positive and Y is coming from the negative. That means the negative sign is associated. So the actual input to the system is U minus Y1. And similarly, the output of the system Y1 जो हमने assume किया हुआ था, that is Y. So when we put this into the equation, क्योंकि यहाँ एक ही process है, only one equation, so we get the representation. Okay, representation of this linear time invariant system, which is nothing but the arrangement of the variables or the matrices जो इसमें involve होंगी, and then uh, the use of this substitution to get this result. And it is also written that because of this inverse, because there is a presence of one inverse value, no? So this inverse value can be zero if D1 become the identity matrix with negative sign. If this value becomes zero, then we have a condition that these interconnections are ill-posed. Okay, because of the singularity. Singularity means the value is primarily zero, and we know that 1 over 0 case primarily lead us to the systems which are not completely uh, specified. So this is how we primarily have a quick review of the terminology which is with this book which we are following. So here, this is just a recap. The general procedure is to obtain the final state space system. Remains the same, that stack the states of all subsystems in a tall vector and compute the differential using the state and output equation of the individual blocks. So we actually decompose a complex system into the smaller blocks into a single block uh, representation, and then we solve and move ahead. And sometimes, because these are the general available formulas, we can use when we encounter the plants which are parallel, which are in the cascade, and which have a negative feedback line. ओके, यहाँ कोई सवाल आपके जहन में आ रहा है? नुमान खान ने ज्वाइन किया जी। नुमान खान, क्या हाल है, आप ठीक हैं?
जी सर, अल्लाह करम।
नुमान, आपके बारे में थोड़ा सा जानना चाहेंगे? आपके बारे में वो कर लिया है, तो नुमान आप अपने बारे में कुछ बताएंगे? आपका नाम तो यहाँ हमें लिखा हुआ नजर नहीं आ रहा है।
अच्छा सर,
आपका क्या स्पेलिंग क्या लिखते हैं आप?
लेकिन सर मैंने तो इस कोर्स में रजिस्टर्ड किया है, NOMAN। और आपका CMS ID क्या है? 2083।
2083। और क्या है आपका ईयर क्या है?
सॉरी सर,
ये पूरा CMS ID बताइए। 208
20-2020।
ताकि देख लो ना। तो नुमान, आपकी क्या मसरूफियात क्या है?
सर मैं अभी जो है जॉब करता हूँ ऑल्सन ऑटो पार्ट्स में, इन इलेक्ट्रॉनिक मेंटेनेंस डिपार्टमेंट। और वहाँ पे
जी, मेंटेनेंस में कौन से ऑर्गेनाइजेशन में?
ऑल्सन ऑटो पार्ट्स, पोर्ट कासिम।
और आपकी बैचलर कौन से डिसिप्लिन में है?
मेरी इलेक्ट्रॉनिक्स में है सर।
कौन से इदारे से?
मेरी अंदर से ही है, मैं हाइट का पास आउट हूँ।
ओके ओके, हम आपको वेलकम करते हैं इस कोर्स में। तो ये मैं एक
थैंक यू सर।
प्रोफाइल अपने पास बना रहा था, मैंने कहा ये भी एक ज़रूरी है, तो वेलकम। आइए, रिकॉर्डिंग अवेलेबल हो जाएगी, एंड देन यू कैन एक्चुअली सी द रिकॉर्डिंग। अभी हम इंट्रोडक्टरी लेक्चर पे हैं। आज का लेक्चर बहुत शार्ट सा होगा, और बस हम तकरीबन कंप्लीट करने ही वाले हैं।
ठीक है सर।
ओके, सो
थैंक यू सर।
ओके, थैंक यू आपका भी। हमारे साथ रहिए। ओके,
जी सर।
सो we move into the system decomposition, in which we have two simple examples. And in these two simple examples, first we see the first example. So first example is the linear time invariant system with an equation which is given here. As you can see, this is the state equation and this is the output equation, and the primarily this is the diagram, which is the block diagram which is associated with this system. So it can be viewed as a feedback connection, like in this, where the integrated system maps each input z to the solution y of z. कैसे? जब हम इसको सॉल्व करने के लिए गए तो हमने ये देखा कि जो अगर हम प्राइमरली y को देखें तो y विल बिकम इक्वल टू x, और x को जब हम यहाँ से सॉल्व करते हैं, ओके, सो z इज द इनपुट, सो z इज इक्वल टू प्राइमरली u minus y, and we can put the value of u here.
u plus y नहीं होगा?
ओके प्लस वाई, ओके थैंक यू, u प्लस वाई, वो मेरे जहन में पुरानी ही वो चल रही थी, ओके u प्लस वाई, and then y is equal to y1 we already know, and then we solve these equations, and finally we get a representation which is like this. इसके बारे में हम मज़ीद जो है वो इंशाल्लाह नेक्स्ट क्लास में भी देखेंगे. These equations are, these primarily examples are given in the book. बुक से हमने ये एग्जांपल्स ली हैं. अभी इनको मैंने खुद भी जो है वो वर्कआउट नहीं किया है. आई विल वर्कआउट फॉर देम. जो स्टेप्स हैं, ऐसे मैं आपको गलत कोई चीज़ बता दूं, बेहतर होगा आई विल वर्क विद. तो पहले मैं इनको खुद वर्कआउट कर लूँ. ओके थैंक यू.
एक रिक्वेस्ट है सर.
जी बेटा बोलें.
सर ये जो एग्जाम्स वगैरह ना थोड़ा वो ब्रीफली सॉल्व करके दिखा दीजिएगा, क्योंकि काफी टाइम हो गया स्पेशलिस्ट किए हुए.
हाँ इसीलिए
तो थोड़ी सी प्रॉब्लम होगी इनको.
जी बिल्कुल बिल्कुल, इसीलिए मैं इस चीज़ को थोड़ी देर के लिए छोड़ रहा हूँ, ताकि असल में आई वाज नॉट प्रिपेयर्ड फॉर इस स्टेप से मुझे आगे नहीं जाना था. तो हम ये एक काम ये कर लेते हैं कि हम यहाँ पे स्टॉप कर लेते हैं. ठीक है, हम यहाँ पे स्टॉप कर लेते हैं, और ये जो दो एग्जांपल्स हैं इनको मैं स्किप कर देता हूँ. इन दो एग्जांपल्स को स्किप कर देता हूँ और इनको हम नेक्स्ट सेशन में करेंगे. ठीक है, ओके. इन दो एग्जांपल्स को हम नेक्स्ट सेशन में करेंगे. दीज आर नॉट डिफिकल्ट, आई हैव टू डू इट. इसके स्किप करते हुए मैं आगे जा रहा हूँ, और आगे जो चीज़ें हैं हम उनको थोड़ा सा देख लेते हैं. दीज आर नॉट डिफिकल्ट थिंग्स. ये आपके उसी सवाल से रिलेटेड है जो आपने पहले सवाल किया, जो हमने जो मोटर के बारे में बात कर रहे थे ना. सो जो मोटर की हमने इक्वेशन देखी थी और उसके बारे में हमने जाना था, थोड़ा सा मैं रिकैप कर लेता हूँ क्विकली. एक इन स्लाइड्स की मैं बात कर रहा हूँ. Okay, so this is the slide in which we talk about the electric motor, and this is the slide where we actually represent the equation in a form जो कि हमें given जो जनरल फॉर्म है उसमें हमने इस इक्वेशन को कन्वर्ट किया था. अब इसमें जो है वो मैं एक जो है वो एग्जांपल जो है वो आपको करवाना चाह रहा हूँ. Okay. Here is the case of a DC motor in which the DC motor is primarily modeled with a circuit in which the input is supplied with a motor. So U become the voltage V. And similarly, the output is in the form of primarily the rotation of this rotor, which primarily moves due to this in. तो इसको हम थोड़ा सा जो है वो देख लेते हैं. So A common actuator in control system is the DC motor. It directly provides rotatory motion and coupled with wheels or drums and cables and provide the translational motion. The electric equivalent of circuit of the armature and the free body diagram of the rotor is shown in this figure. In this figure, we also have shown the fixed nature of the magnetic field. So the input is V, the voltage, and output is the rotation. Okay, it is mentioned in theta. So, and the friction torque is proportional to the shaft angular velocity. There are physical parameters which are written here. The moment of inertia of the rotor. Typical values are given on the right side. From a website जो मैंने नीचे लिख दी है. Then motor viscous friction constant represented with B, electromotive force constant, motor torque constant, electrical resistance, and electric inductance. So these the typical values are given, and similarly the physical parameters are given. Because this is just an example, and I am not in driving the relations, but we are using the direct relation. So the equation which is given from that resource is given here. So this is the equation in which you can see the x primarily, and similarly the a, and similarly we have x here. This is primarily A, B, and C and D matrices, A and B matrices. Similarly, we have the voltage in term of U, which is the input. And we have C here. And D is 0 in the equation. So this equation I just picked from that website. And this is the equation which is written, and it represents taking these parameters. तो इससे हमें एक चीज़ का आइडिया जो है वो ये हो जाता है कि वी कैन हैव ए रिप्रेजेंटेशन ऑफ डिफरेंट सिस्टम्स जब हम उनको इक्वेशन की सूरत में लिखेंगे. सो यहाँ 2 की बजाय 3 भी हो सकते हैं. जैसे उसने कहा था कि वेक्टर्स जो है वो मल्टीपल कंपोनेंट्स भी हो सकते हैं वेक्टर्स के, 3 भी हो सकते हैं, 4 भी, एंड सो ऑन. सो दिस इज द इक्वेशन जिसकी हम बात कर रहे थे, जो हमने उस प्राइमरली उसमें शो किया था, एंड इट हैज़ ए रिलेशन विद दिस डायग्राम, दिस प्राइमरली दिस इक्वेशन. इसके बाद जो लास्ट में हम प्राइमरली रिव्यू करना चाह रहे हैं वो ये है कि हाउ टू यूज़ द कंप्यूटर प्रोग्राम्स टू सॉल्व रिप्रेजेंट प्राइमरली इनिशियली एंड देन मूव टुवर्ड्स द solution of those problems. कैसे हम करेंगे. तो सबसे पहले मैटलैब का प्रोग्राम देखते हैं. इन ए सिंपल मैटलैब प्रोग्राम जिसमें रिप्रेजेंटेशन की अभी बात हो रही है. सो वी इनपुट ऑल द पैरामीटर्स and use a transfer function, a function which is abbreviated as TF, to actually write the transfer function in the MATLAB. Then we can enter the equations and then make a state space model of motor in this way, in which we specify the matrices A, B, C, and D. When we print this in MATLAB, we get the value of A, B, C, and D. These vectors. So in this way, we can use the MATLAB to represent a state space system when we are talking about the MATLAB. When we are using the Python, because Python is a free primarily software tool, so usme we are using the control module, and in control module we enter the parameters, and we can write the transfer function by using the matrices, which is more simpler form. अगरचे हम equations भी use कर सकते हैं, but the same output, and we can enter the system matrices and their values, and then we can make a system state space model by using these A, B, C, and D matrices, and the answer will be the same as जो कि हम MATLAB में कर रहे हैं. तो मेरा तो जो वो होगा गाइडेंस होगी कि